Let's take a look at a lab problem from section 11.1. This is problem number 2. Determine whether the sequence converges or diverges, and if it converges, find the limit. Our sequence is a sub n is equal to, we have 1 plus 10 over n in parentheses, all raised to the 5n power. Now we're going to take the limit as n goes off to infinity for this sequence, and we're going to notice that there's an n inside and there's an n in the power, and so we're probably going to need some help using logarithms and L'Hopital's rule. Also, as n goes off to infinity, this 10 over n goes to 0, and so inside of the parentheses we'll be left with 1, and then we have the power going to infinity. 1 to the infinity power is an indeterminate form, and so L'Hopital's it is. First thing we're going to do is we're going to set the limit equal to some value, some variable y, and then we're going to take the ln of both sides. So the ln of 1 plus 10 over x raised to the 5x power is going to be one of the properties for exponents, or for logarithms, which is why we're using it, is to be able to bring this power down as a coefficient in the front. And so this expression will be equivalent to 5x times the ln of the rest of the thing in parentheses. So now that we have that, we will write this. This is, as x goes off to infinity, this is going to be infinity, and x goes off to infinity, this is going to be 0, and then you'll be left with 1 in the parentheses, and the ln of 1 is equal to 0. So we have infinity times 0, which is indeterminate. And for us to be able to take advantage of L'Hopital's rule, we need this to be a fraction. So this 5x goes in the denominator. But you can't just put it in the denominator. You have to multiply by the reciprocal, or in backwards term, we have to divide by the reciprocal. So if you take a look at this expression, ln of 1 plus 10x, 10 over x, divided by 1 over 5x, that will amount to multiplying by the reciprocal of 1 over 5x times the ln. So now we have a fraction, and now we can take L'Hopital's rule. So, by the way, we can take L'Hopital's rule because as x goes off to infinity, 10 over x goes to 0, and you would have 1 left in the parentheses. Ln of 1 is 0, and then 1 over 5x as x goes off to infinity will be 0. So we have 0 over 0. According to L'Hopital's rule, if this limit will exist, we're going to take the derivative of the numerator, and the derivative of the numerator is 1 divided by, the derivative of ln of something is 1 divided by that something, times the derivative of that something. So the derivative of this is, the derivative of 1 is 0. The derivative of 10 times x to the negative 1 will be, the derivative is going to be negative 1 times x raised to the negative 2 power. Times 10. So we have 10 times x to the negative 2 power. So that can also be neatly written as negative 10 divided by x squared. All right. Now, before we go on and keep taking L'Hopital's rule, what we need to do is we need to simplify this. So it looks like we can cancel a negative. There's a negative sign here and a negative sign down in the denominator. We can cancel a 1 over x squared, 1 over x squared. And then we can imagine this 5 in the denominator going up to the numerator being multiplied by 10. So we have 10 times 5. And then we have 1 over this whole expression over here. So let's drop that expression down in the denominator. 1 plus 10 divided by x. And we're going to take the limit as x goes off to infinity, and 10 over x as x goes off to infinity, 10 over x goes to 0, and so we're going to be left with 50. So it might look a little confusing because you're not seeing the canceling here, but I highly suggest that you write this out and then simplify it in the way that you can see it, so you can see things cancel out. All right, so we got 50 over here, but we have to remember that the original limit, this is not our original limit because we had to take the ln of both sides. So we have to undo what we did. So we have y is equal to 50, and then, or ln of y is equal to 50, and so we have to take e of that. So our final step, if you remember back from Calc 1, when we were doing L'Hopital's rule, if you take the ln of both sides, you have to undo the ln by raising it as a power of e. And so we have our final answer, that limit, or the series here, converges. The series a(n) converges, and it converges to e to the 50th power. Okay, I hope that helps.